Okay, Chapter 11, Section 4, Measures of Variation. Calculate how widely the data points vary from each other using range, variance, and standard deviation. So we spent the last one on measures of central tendencies. That's another way of saying what is the average number. We did the mean, median, and mode, mid-range, that kind of thing. So we were trying to look for the center of the data points, the data values. Now we want to figure out how wide they go. What's their spread? Are they really varied or not varied so much? Do they all cluster around the same thing or do they really spread out? So we want to use the range that we've looked at before to calculate the class width. Done that before in lesson 1, section 1. But that ignores all the data in between, and the range can be strongly influenced by the outliers. Even the mean, the average, can be really pulled one way or the other by the outliers. The variance and the standard deviations are more reliable measures of variation. The standard deviation provides the approximate average distances between the data values. That's really what it is, the average distances between the data values, how far they are from each other and from the mean. We're going to practice below using this procedure to find the variance, which then you take the square root of to find the more common standard deviation. Okay. Let's handle the symbols first. We need the variables s raised to the second power is actually called the sample variance. Okay. The population variance is something different symbols. Okay. S is just the sample standard deviation because we take the square root of the variance. Okay. When we discuss variations, we typically use the standard deviation. You'll almost exclusively. We hardly ever use the variance, but remember, we're finding this, square rooting it, and then getting our standard deviation that we use all the time. Okay. So remember, X bar stands for your sample mean, and the sum of all the X values, you total them up and divide them by the total number of data values will give you your sample mean. So we need that because it's in this formula over here for your sample variance. This is the sum of, and then what happens is each data value has the mean subtracted from it. Okay, so we have to find that mean. And then the sum of them all squared over n minus 1. Remember, n was sample size. Okay, so we need to, the easiest way to do these is in columns. So we'll do that at the bottom. Okay, so we're just going down here. List the data vertically in a table or list. Then you're going to, next to each data value, you're going to subtract the mean. And then we're going to then square it and get the sum of the squares. So notice where the parentheses are in this. This is the sum of all of these numbers squared. So remember, the sum is at the end after you square them. So I'll need a column for the data values. Then I'll need a column for the mean being subtracted from them. Then I'll need a column for those numbers being squared. And then I will add up this column and then divide this by whatever this number is here from the sample size. Okay, so here are the columns here. We need to get the sum of the squares, which is in the bottom of this column, and then divide the whole thing by that to get the variance, and then take the square root. Don't forget to take the square root of all this work, okay, for the variance to get the standard deviation. All right, so here's a sample, an example that we need to do all this for. It says find the range, variance, and standard deviation for the weight of 8 dogs. What does the standard deviation tell us? So here's my data values. They're not in order. It doesn't really matter for this. Let me just write them here. I almost want to put them in order, but I can't think of a reason why that matters. So let's just put them in here. If you're doing this in Excel, they have to go straight down. If you're doing these in your calculator, it doesn't really matter. I just need a list of them all. Okay. And then I need to find the average. I need the X bar, which is the sum of all the data values together divided by the sample size. So our sample size is 8. And then I need to total this column, and apparently it comes out to 512. And then what I need to do is go 30 minus, sorry, I'm jumping ahead. This is definitely going to be 30 minus, but I got stuck because I still didn't figure out my mean. So this is going to be 512. I just did that here, divided by this 8. And this is going to be 64. I just want to double check before I do all of this stuff. There's definitely a 64. Let me check this 512 just to make sure. Get in the habit of adding a bunch of string of numbers together accurately, because you can see how, I mean, even I'm double checking that this is 512 divided by 8 is 64, because we're about to use this a bunch of times. So if this number is wrong, it's really going to mess you up. All right, so each data value needs to be subtracted. And notice the order. It's very important you stick to the formula order, no matter what the numbers are. It's the data value minus the average that we just calculated. Whoops. All right, and hopefully I did these right. So you will get negative numbers. That's okay. It is what it is. And every one of these numbers better be correct, or it'll throw off everything else. All right, so then I need to square whatever that number is. So notice that the negatives get taken care of when you square it. This comes out to 3721, 484, 121, 16. And there's no way to know if these aren't correct unless you just keep double checking yourself. Okay. Then I need a total of this column. So go ahead and email me if any of these numbers are incorrect. I need to get my variance here, my sample variance, by putting the sum of this column. And this will be 8 minus 1. And this comes out to, and you'll get a lot of decimals. You need to keep all of them. Technically, 6 rounded properly, or 7. You need to take all these decimals because you then have to square root this. So this is the variance that needs to be square rooted. The whole thing needs to be to get all the decimals to come out right. And then round whatever this standard deviation is to what Alex wants. Okay. So if it doesn't tell me when I'm doing it by hand here, I typically round it 1 decimal past what the values are. So what is this telling us? The average weight of these 8 dogs is 64. This is the sample mean. Okay. the sample variance, which can't really relate to what that means, but a swing of 30. I mean, look, you had a 30 and a 125-pound dog. I mean, there's a big swing. Okay. So that means that they vary a lot. I mean, I know you could have looked at that, but that seems reasonable. Okay. If you had a very low number and a very high number, and all the rest were kind of in between, so your variance would be a lot lower if it wasn't for those two. So this is my sample standard deviation, and this is my, sample variance sample. And we're going to do a lot with that. So we got to make sure that we understand how to do that. Okay.